Now, let's talk about a very simple reaction, and this is a reaction we can conduct on aldoses and ketoses that we prefer to do this on aldoses because effectively what we're doing is lengthening the chain of aldoses. So, if we have an aldose, and we'll start with a simple one. This D complex. And we add potassium cyanide, KCN. Well, the reason we're adding the potassium is that it's just kind of a spectrum atom. So we've got this cyanide atom, or molecule. And what it's going to do is it's going to do a nucleophilic attack on the aldehyde. And we're going to get, as an intermediate, this compound. Now, what's the issue with this? Well, here's the thing. I've drawn this little squiggle line here. We are attacking a carbonyl, and we can, because it is a trigonal planar molecule, we're not going to get selectivity or for the RS or the L and the D. So we do this initial addition of the cyanide atom to, this should be to the sugar to get kind of this alkoxide. What ultimately ends up happening is that we get a sugar, we extend the chain by one carbon, get the nitrile group on the end, and we get both the R and the S configurations for the alcohol. Now, we're going to follow this up with this. Now, this H2H2O is actually serving two purposes. So if you look back to a previous video, you can look at the reactions of nitrile groups with water. And if you do this under heated conditions, what you'll ultimately produce is a carboxylic acid, and ammonia. Or in this case, because we're currently under basic conditions, we're going to end up producing the carboxylate ion. Now, this PDBaCO3 with your H2, this is your Lindlar catalyst. And what this is designed to do is reduce the carboxylic acid we form back down to an aldehyde. So when we finally run this reaction with all these conditions, we end up recovering an aldose. So the advantage of this reaction is that we can extend the length of a sugar chain repeatedly by adding this potassium cyanide and then cycling through this H2, HCO, or some type of variant of Lindlar catalyst to give us successfully longer aldose chains. Now, major disadvantage is that for each carbon length we add, the alcohol beneath it is no longer selected to R and S. So if you want to add carbons to a sugar, you're going to have to and do this selectively for the L and the D or the R and S. This is something you're going to do biologically, but synthetically in the lab, under something we can do, this is the best we can do.